Hello, how to solve n times n times n equals 1 divided by 27, solving for all values of n that satisfies this equation. So n times n power 2 times n, that is n power 3, equals 1 divided by 27. So from here, I can have n power 3 equals, I can raise this 1 to the power of 3 because it is the same thing as 1, divided by 427. I can express it as 3 power 3. Now, if you have a power c divided by b power c, this is just like writing a divided by b to the power of c. So I have n power 3 equals 1 divided by 3 raised to the power of 3. I move this over here to form a cubic equation. I have n power 3. This becomes 1 over 3 raised to the power of 3. And this equals 0. So we have power 3 here. We have power 3. So let's expand this using this identity. If you have a power 3 minus b power 3, this equals a minus b times a squared plus ab plus b squared. And our a is n, while b is 1 over 3. So I'm going to have n minus 1 over 3 times this is n squared plus n times 1 over 3 plus 1 over 3 to the power of 2, and this equals 0. So from here, I have n minus 1 over 3 times this is n squared plus n divided by 3 plus, we share this exponent to each of the terms, that is 1 power 2 divided by 3 power 2, and this equals 0. So from here, I have n minus 1 over 3 times this is n squared plus n over 3 plus 1 divided by 9, and this equals 0. So what we are going to do will be to equate each of these to 0. We have n minus 1 over 3 equals 0. That means n equals 1 over 3. That's our n1. To solve this other one here, we need to equate n power 2 plus n over 3 plus 1 over 9 equals 0. So we need to find the common LCM here. Is over 1. The common LCM is 9. 9 divided by 1, 9. 9 times n squared. 9 squared plus 9 divided by 3, 3. 3 times n. 3n plus 9 divided by 9, 1. 1 times 1, we have 1 equals 0. This over 1, we cross multiply. 9 will multiply 0, that is 0. This multiplies 1. We have 9n squared plus 3n plus 1, and this equals 0. Now let's solve this quadratic equation to find the other values of n. We are going to make use of the formula method. We have the formula in respect to n. This is b squared minus 4 times ac and divided by 2 times a. This 9 here is the coefficient of n squared, that is our a. 3 is the coefficient of n, that is our b. This is the constant, that is the c. So from here we have n equals negative b, that's negative 3, plus or minus square root of, this is 3 power 2 minus 4 times 9 times 1 divided by 2 times 9. So from here we have n equals negative 3 plus or minus square root of, this is 9 minus 4 times 9, that is 36 times 1, that is 36, divided by 18. So from here, we have n equals negative 3 plus or minus square root of, this is negative 27, because this will subtract 36, so we have negative 27 divided by 18. So from here, we have n equals negative 3 plus or minus minus, here we have square root of negative 1 times square root of 27 divided by 18. So from here, I have n equals -3 plus or minus square root of -1 is iota. I times square root of 27, I can express it as 9 times 3 here, divided by 18. So from here, you have n equals -3 plus or minus I times this is square root of 9 times square root of 3 divided by 18. So from here, I have n equals -3 plus or minus I times square root of 9. This is 3 times root 3 divided by 18. 3, 1, 3, 1. This is 6. So from here, we have -1 plus or minus I root 3 divided by 6. So I can easily factor out 1/6 from here. I have 1/6 times -1 plus or minus I root 3. So we have two complex values for n, which are n2, because we have gotten our n1 already, which is 1/6 times -1 plus I root 3. And n3, the 1/6 times -1 is 10 minus I root 3. So these are the two complex values for n, and we also have one real value for n, which is 1/3. We can easily check for the real value. That is very simple. And our n is 1/3, meaning that you have 1/3 times 1/3 times 1/3 equals 1/27. Multiplying the numerator 1 times 1 times 1, you have 1 divided by 3 times 3, 9 times 3, 27. And this equals 1/27. So guys, that is it for the real value. And we have been able to test it. So the solution is correct. 3 solutions, 2 complex and 1 real solution. Goodbye.